Good morning, plumbers over the country. I'm pretty sure we're going to have a very nice little chat this morning. My name is Dion Smith, as you can see there. I'm the owner of a company called Independent Water Heating Solutions and Training. I do plumbers training on water systems, hot water systems nationally, all the provinces, and I do that under the banner of the training center of QuickHot. So, we are very busy, and it's a pleasure this morning to assist you in terms of talking about the open vented water heaters as such. Right, so the electric water vented heater, electric open vented water heaters, also referred to as push-through water heaters or point of use. These water heaters are a specific category as contained in the SANS regulations. And SANS 10254 2017, as you all know, is the regulation that handles or deals with the installation of water heaters. Now, these electric open vented push-through water heaters, forms obviously part of that. I just want to point out that many people talk about a point of use. That means that that little water heater can only be used where it is installed at that one specific point. You cannot have more than one point of use connected to this water heater. The definition of these units is the following. As it says here, these water heaters are classified as open outlet types and operate at 0 kPa with the outlet open to the atmosphere. So no pressure, it's open vented, and that is why this is very, very important. Also to understand the concept, obviously, that we will discuss today. Now, reference here to SANS 151. Now, that is the regulation that governs all geysers per se, water heaters. And any tank geyser in South Africa which contains a tank, an inner tank, falls under this regulation. Now, you can see there's three types of water heaters: your cistern type, then you have your closed type, and then dedicated additional to that is your open outlet type. So you can see there the point is made that the cistern type, if I may use an example, that is going to be like a solar low pressure system where you've got a little cistern on top. I'm just using that as an example. There's no TP valve with those ones. A closed type geyser, that's your normal pressurized units that you all know about, from 50 to 450 liters. They do have a TP valve. And then your open outlet type that we're going to refer to today, they do not have a TP valve. And that's a critically important point to remember. Now, the national standard references, like I've said now, is SANS 151, fixed electric storage water heaters. And section 3.1.19.3, it says the open outlet type storage water heater in which the flow of water is controlled. Let me just get this thing out here. Just one sec. Controlled with valve in the inlet pipe, and in which the expanded or displaced water flows through the outlet from the heater. Now, that concept we are going to refer to this morning as well. Then later on in that same regulation, section 8.2.1, operating instructions, they say each water heater shall be supplied with a leaflet, which is obvious. I don't want to spend time on that. Now, in the red writing, it says there, in the case of an open outlet type water heater, the leaflet shall also contain an instruction stating that the outlet acts as a vent and shall not be connected to any form of tap or fitting. So that is the point. So the open outlet effect is created by using the spout of that mixer as your vent. This here just helps us to appreciate all the different regulations. I don't want to go through that. We don't have time for that. But if you can just cast your eyes right down to the bottom, section 8.1.1 under general. There in B, the very last sentence there, the last part of that, it says open outlet type, system type water heater shall be marked 0 kPa. And that's the point I want to make, that these things are 0 kPa rated. Now, also part of the national standard references is SANS, that's 60335-221, safety of household and similar electrical appliances. And here they also make the point. Section 2105, open outlet water heater, storage water heater in which the flow of water is only controlled by a valve in the inlet pipe, which the expanded or displaced water flows through the outlet. So I have all these regulations just to make the point that this is not somebody's little toy that they thought about. This is all contained in the SANS regulations. And that you can see here again, here they've got in the SANS 60335-221 these little pictures here where they actually depict these two type, over basin and under basin type of unit. Right, now let us get back to our most well-known regulation, SANS 10254-2017. Specific requirements 413 for assembly of these units for an open outlet type water heater, an outlet which shall not be threaded or in any other way be allowed to be blocked, and a control valve in conjunction with the swivel type outlet or otherwise a mixing control valve unit of a type as shown in figures 10 and 11, and the cold water supply connection between the control valve and the water heater shall be furnished with a spring-loaded non-return valve. Now, guys, this is very, very important that we understand this concept, and it is in our SANS 10254-2017 regulation. So let us just have a look here. Now, this is the figure 9 that I referred to. This depicts over basin open vented geyser. Now, you can see the water main supply there at the top comes down, and then it's going to go through a control valve. Now, that control valve they depict here is the most basic way of allowing water or to get water into the system and then obviously to withdraw it again. Now, as we've seen before, that control valve, which is basically a stopcock, between that stopcock and the inlet to the geyser, there must be a spring-loaded non-return valve installed. They do not show it here, but they tell you in the regulation that is the case. Now, what I want to point out, this is the only time with all the installations and the pictures and whatever they say here, where a non-return valve is going to be used. And I'll come back to that just now. So you can see here that spout there, the water outlet, that is a swivel type. And I'll show you some pictures of that as well at the later stage. This is the most common mixer that is used with these over basins. In other words, where the water is, the geyser is sitting mounted on a wall, and then with the outlet pointing down towards the basin. Now, this one here is the normal one that you will find that people are installing, and this one creates the least problems in terms of understanding the situation in terms of that, because you just connect this mixer to the cold inlet, the hot outlet, and obviously then your outlet at the bottom as well. This one here is for a under basin, and this is where the most problems arise in the field. You can see here that this mixer has got 3 ports or 3 pipes, one for the cold, one for the hot outlet, and the other one also on the hot side feeding. And I'll explain that to you now with my next slides. So one on the right-hand side, one on the left-hand side bottom, they are both shown in the SANS regulation. But the one on top left, that is a drawing that I got from a very good friend of mine, which helps us just to understand the flow inside that thing. And that one here is the same thing, just exploded. Now, what happens here is that your cold comes in at the bottom. You've got your cold tap on the right-hand side. If you close that, the cold water from the main supply is directed through porting on the inside to the so-called left-hand side where your hot water outlet is. Now, that cold water flowing through that port is then the pipe on the left-hand side is connected to the inlet of your little geyser. That is where your blue indicator is for the cold receiving port. Just remember, we are talking here about a under basin system. Now, the middle one, you will see there's a return from the geyser hot outlet. So what happens here is the cold water is going to be directed from the mains through the porting on the left-hand side, which is your so-called hot water tap. And then there's a dropper pipe on the inside of that tank. It directs the water to the bottom. The water then, when heated, is then replacing, because the water is dense, it's heavy, it's at the bottom, and the water then floating on top at the hot outlet is going to be pushed out of your spout, and that is how this thing operates. So very, very simple, but this helps you to understand and appreciate the actual porting of the pipe work on the inside of that mixer. Now, let us quickly have a look at some correct installations. This one here is obviously a correct installation, because what we have here is that we've got an open vented mixer. The previous picture I showed you, that's depicting an open vented mixer. You cannot have a normal mixer with a cold and hot, because if you do that, you are not going to have the open vented effect from the inside of the geyser through the spout to the atmosphere. Now, this one here, it's got 3 pipes, cold inlet from the mains, and then obviously your directing of the pipes inside the little mixer to the cold inlet and the hot outlet as such. This here is another one of a mixer like that, and I just want to point out that these mixers are very, very sort of like, it's a law. You have to use them, otherwise you're going to create a bomb, and I'll show you what these things do when they actually explode. So 3 ports, that is what you want. Right, now we've got a few pictures of incorrect installations. So let's have a quick look at that. Now, these ones are incorrect because there is not a push-through mixer used there. You can see the one on the left-hand side, you've got just a basin with a hot and cold water tap. By having it like that, you are going to have a problem, because you are actually pressurizing the unit above it. Yes, exactly the same thing. It is going to be pressurized, and you have a potential major problem. There's another one that was installed, picture taken in the field, where this person trying to put vacuum breakers on it. These things are not installed with vacuum breakers. This one here, the same thing. And this little figure 3 at the bottom, that little valve is not a safety valve in the true sense of the word. And so we cannot use that. And I'll refer to that a little bit later on as well. Now, guys, I've got a few pictures here. Now, I want you to understand one thing. I'm totally neutral. I've got manufacturers' examples of what they sell. It's not only Quickot. We've got Heattech, the other companies as well. But I use these slides just to point out that in this one here, Quickot says, you can see there in the middle, they say the underbasin unit must only be installed with this mixer, this push-through mixer as such. Okay, so keep that in mind. And then the second point that is, or sentence underlined there, the point of use geysers are rated at 0 kPa in South Africa. Okay, so this means that you cannot pressurize these things. There's another one from the brochures. They say the underbasin unit may only be fitted with a counter surface push-through mixer, which is not supplied, and the overbasin unit with an overbasin push-through mixer not supplied, or with stopcock and spout not supplied. Now, the point is that my initial pictures of the SANS regulation actually refer to that as well. That is just a cutaway of the Quickot's product. That is an overbasin one. And you can see that pipe there in the middle. That is not an anode as such. That is a pipe from when the water is heated, floats up to the top, and then when you open up a hot tap, it's going to flow down that little dropper pipe there. And there's the other one as well. They don't show the dropper pipe here, but believe me, there is a dropper pipe directing the water from the top to the bottom to displace the hot water through the spout with your mixer. That's what these underbasin mixers look like. You can see the 3 pipes there, and very, very easy to assemble. They give you a little brochure with it, and so there's no problem. That is your overbasin one, very easy to install. And once again, hot and cold, and your water comes in from the back to the mixer from the inlet from the outside, and then you can see the swivel outlet there as well. When you use the stopcock, this is the product. That's a normal stopcock, and just remember that between that stopcock and the inlet to the geyser, you have to have a non-return valve, but must be spring-loaded, and then obviously this chrome swivel outlet you can buy as well. Now, even with the heat tech, they have the same story. You can look at the bottom there. They say the over zinc and under zinc unit must be fitted with a push-through mixer, or with the stopcock and spout. So you can see all the manufacturers, they refer to the fact what the law says, and the law says it must be done like that. We've got no choice. Right. Now, types of water heaters, SANS 151 closed water heaters. That's a normal geyser per se. And I want you to just understand here. Let's read it. It says storage water heater that's unvented, that's intended to operate at the design working pressure of the water heater and the flow being controlled by one or more valves in the system. Now, that's what you're used to. That's a normal geyser. Now, I've got a few slides here, examples of closed type pressurized, another points of or point of use water heaters. And I want you not to get confused, guys, because in the industry, when you say point of use, most people just think about a push-through geyser as a point of use. You actually get point of use geysers where it's a closed type. And this is the type of geyser I'm talking about. Tectron, Cape Town, they have these geysers. And notice the point. On both the models here, they've got a TP valve. And that is the point. TP valve on these ones, the pressurized point of use geysers, like here. So you can see they refer to it as a point of use water heater, and whatever it goes, where it is installed, that is at this stage not the issue. But you can see there's a TP valve, so it's a normal closed top geyser. Results of incorrect installations, critical, very, very dangerous. We can have even explosions. And my question is, does high pressure cause a geyser explosion? Answer is no. Only superheated water can cause a geyser explosion. And if you are going to pressurize one of these little ones, guys, a 15-liter geyser push through, if it is pressurized, the explosive power of that thing is equivalent to 7 hand grenades exploding simultaneously. And when it is in a building, all that power, or it's amplified, and people can die. So here's just a slide to show that if you pressurize that thing to a 400 kPa or 400 kPa geyser at 152 degrees Celsius, that water, which is now in a superheated condition, is going to turn from liquid to steam, and you're going to have a major explosion. That's a hand grenade. I told you 7 of them with a 15-liter, and that is what happens when these things explode. This photo was taken in 2003 in Krugersdorp, and you can see the damage that was caused by a 15-liter overbasin unit where it actually took out that flat. Nobody died there, but people could have died as well. That is now when the plumber who's ignorant is installing these things, and obviously you can see where the plumber goes, you can see where his boots are, his Bob John spanner, and all his geysers. So be very, very careful. This is just to show you that how a safety valve works, which these little geysers do not have. This is a valve opening under temperature. As you know, your wax inside the probe is going to melt. It's going to open the geyser. That is with the point of use of Tectron. That is, they are fitted with these things like your normal geyser. Your other little push through does not have that. That's under pressure. The same thing. If that thing is pressurized, obviously it's going to open eventually under pressure. Now, guys, this here is the little valve I was talking about. I may be crucified for this, but you can see here this valve, often sold with open water heaters as a non-return safety valve, does not comply with SANS 118, which is your safety valve regulation, and SANS 180810, which is your non-return part of the regulations, and may not be used in SANS 10254 for geyser installation. So there's no need for this thing, because you will never find that the geyser, if installed with a open vented mixer, that they will be over pressurized. You don't need this thing. It's only once you need it, and that is when it's an overbasin. You use a stopcock, and then you have to have a non-return in between the stopcock and the inlet to the geyser. So just to help you to understand that this is a section here in SANS Regulation 10254, that if you go on site and you find one of these things with a pressurized normal mixer, then you have to tell the client that this is non-compliant. And you also have to issue a COC. Like we know the story about COCs. You cannot issue one when you install one of these or see it installed when there is not a push-through geyser. I hope you enjoyed this. I hope you have lots of questions, and I hope to assist you in future. If you need any information, you can contact me anytime. Thank you very much.